let's move on to building the actual rig. First, we need to gather all the data from our three UI blocks and pass it into the create rig button. Let's go to this create rig button file, and let's add 3 input parameters for this class. It will be a locator field, a curve field, and a number field. So let's store these 3 parameters after we getting this to the class attribute, so that we can access them both from inside and outside the class. So let's just copy all this stuff and do this. As a locator field will be self locator field. As a curve field will be a self curve field. And the same for the number field. Now, let's go back to our UI main and modify the button initialization. So here we have to pass all information from our input fields. So let's put this here. Locator field, curve field, number field. Like a locator field, we will be use. Let's go to our here. We need an object name field here. So as a locator field, we will use controller block object name field. As a curve field, we will use path curve block object name field. And for number field, we need, let's check. We need a block elements number. So like a number field is object number block elements number. Okay. So this way we pass all 3 user interface input fields to the create rig button. Okay, let's return to our rig button file, and let's connect buttons clicked signal to some method. Self clicked connect with self create rig. So let's discuss this method. The first thing this method should do is get the locator from the scene and create a controller at its position. This controller should have a custom attribute with a specific name that we will later use to drive the rig's behavior. And once the controller is created, we will remove the original locator as it will no longer be needed. So yeah, let's do this. We will use some Maya commands. So let's import Maya commands first. And also let's define an attribute name that we will assign to our controller. We need this. We need to save this like an attribute of our class. Self control attribute name. So rotate. Now let's implement this method to our code. Let's I do this first, and after that we will do a line by line breakdown. So what we have here. First of all, we are getting the text value from the locator input field and gather it to the target object variable. Also, we check whether the object with that name exists in the scene. If not, we stop and show a warning message. We enter try block to catch any additional potential errors and prevent Maya from crashing. Commands X form with some flags. We need this to get the position of the selected object in world space. So what's the flags we are using here? Q, it means the query parameters. It means that we want to get the information, not to change something. World space, it's about world space. We need our transforms from world space, and T flag is the transforms. So we need to get the transform position in world space, and we need to get it, not to change it. Next, we create a circle controller with some radius and some name. I suppose that it's clear. This command return two objects. First of all, it's transform and the shape transform and the shape node. So we store only the transform node. We don't need the shape node. So this is why we use this construction. We don't need a shape node. We ignore it. Next, we move the controller to the target position using command xform, but in this case we don't use a Q flag as before, because we need to edit our position, so we don't need a query. And what next? Yeah, we were using world space, and we use our target position for this transformation. Next, we add a custom attribute to the controller with the add attribute command. What we have here, long name is the name of the attributes, of course. Attribute type float, that is what necessary for us. Also default value 0, of course we need this too, just to be sure. And the keyable true makes it available for animation. Next, we delete the locator object since we don't need it anymore. And of course, except if any error occurs, we catch it and accept the block and show a critical error message instead of give a Maya opportunity to crash. Okay, we can save this, and let's do what we want. Let's create a allocator in the Maya scene. Let's move it to any position, and put it to the first input block, and let's just click the create rig button. So we see that the locator disappeared and the controller appear in its place with the specified custom attribute as we expected. So let's try to trigger some errors just to check our exception. Let's let's leave the locator field empty and click the button. Read. Also, what we can do, we can select some locator in the scene. It puts to our field. Let's delete it and try to click on the button. Yeah, and we see that everything is okay, nothing crashed, and we see a message that something was wrong. Okay, perfect. The first part of our logic works. Now let's add two more validation steps before we continue. So since we already have a curve name and number of elements, let's get the text and the value from these fields here in our method. Curve name is the self curve field. Text is the method which help us to get the text. And for example, num elements will be a self number field. We have to get a value from this. Okay, now let's check this values. For example, if we can just copy this block for our first curve name, and for our num elements, we can do this. If num elements less than 2, we can do the same, but with different message.